Ever wondered why water, something so essential to life, doesn't catch fire? You know that water is made up of hydrogen and oxygen molecules, right? Hydrogen is highly flammable, and oxygen supports combustion. Okay? Did you find this question interesting now? And do you want to know why doesn't water burn? Before I dive into the physics and chemistry behind this intriguing question, I wanted to ask you to pause the video and make a comment about why this does not happen. Or if you think it is possible, why cannot we make the water engine? Imagine a world where water, the most abundant resource on our planet, could power our vehicles and machinery. It sounds like something out of science fiction, doesn't it? Stanley Mayer, an inventor ahead of his time, around the 1980s, claimed to have developed a water engine that could convert water mist into oxygen and hydrogen, the very components that make up water itself. Yes, and in that case, or if could make cars that ran on water, we would not have to pay a penny. Wouldn't that be nice? This concept, known as water splitting, has the potential to revolutionize our energy landscape. Hydrogen, derived from water, is a highly flammable gas that can be used as a clean and efficient fuel source. Imagine a world where vehicles emit nothing but water vapor, eliminating harmful carbon emissions and reducing our impact on the environment. Unfortunately, despite Mayer's claims and aspirations, the reality of a fully functional water engine remains elusive. The technology is complex, and there are significant challenges to overcome. To understand it better, we need to know a little bit about both the chemistry and physics of water. I think you'd agree with me that if the water splitting was that easy, we could just go to the river or a lake and collect the hydrogen as we need it, right? Well, we can still break down the water into hydrogen and oxygen, gases by a process called electrolysis. The electrocatalytic water splitting involves the hydrogen evolution on the cathode and the oxygen evolution reaction on the anode. The process itself is not that complicated, but the energy required for water splitting is 237 kilojoules per mole under standard condition. This is a lot of energy to get the hydrogen from water or to break the water. In simple terms, water is very stable. This is why the idea of harnessing the power of water for energy production remains a tantalizing prospect for scientists and innovators around the world. In addition, water has some interesting properties, including high specific heat, and requires relatively a longer time to cool down or absorb a lot of heat before the temperature rises significantly. This property helps to extinguish flames, making water an effective tool for firefighting. About the non-inflammable property, the key lies in the way water molecules are structured. The hydrogen and oxygen atoms in a water molecule are bound together by strong covalent bonds, meaning they share electrons. So, in summary, while hydrogen is highly flammable, water itself is not. Its molecular structure and lack of a fuel source prevent it from catching fire. Next time you reach for a glass of water, remember its remarkable properties that make it essential for life and its inability to burn. As we continue to explore the possibilities of water as a fuel, let's remember the importance of curiosity and innovation in shaping our future. Stay curious and remember to stay safe.